Continuing our review of area and perimeter, so these are parallelograms. Now the two parallelograms I have here are the same. I've just left the dimensions off of this one for a second so we can play around with it. So when I'm looking at the area, so the inside portion that fills up contained by these outside lines, you'll see that if I was to try to look at it, I don't have full squares. I've got like this little triangle here and another little triangle here and another triangle there, and it doesn't really work out as nicely as the other ones did. So if I had you in class, what I would have you do is I actually would have printed this out for you, and I would tell you to take your scissors and cut along this line right here so that we make a nice 90-degree angle. And you'll notice that when I cut right there, it looks like I've gone a distance down of 4 squares, so we'll say 4 squares, right? And then 3 squares going this way, okay? So like this, 3 squares. And I would have you take that triangle that we just cut off, and I'd have you move it over to this end here. So you can see, look, 4 going up, 3 going across, and then when I look at adding this part in, and I've gotten rid of this part here, what I've really done is I've changed it into a rectangle that has a height of 4 and then a length or a base of 10. I got a 4 and I got a 10. So really the parallelogram here is going to have the same area as that rectangle with dimensions of 10 and 4. So when I'm looking to find area of a parallelogram, what I need is I need this side length here, the base, which in this case is 10 centimeters. And then if you look over here, I've got 5 centimeters along the outside for this line. But when I'm looking at area, I don't care about this slanted line. What I need in order to do area is I need a 90-degree angle that goes from the base or the bottom up to the top. And that is what's going to give me my height. And as you can see here, when we draw from the bottom to the top, the height of this parallelogram is 4 centimeters. And so just like we talked about, if I was to slice this triangle off the side and add it onto this side, I'm really creating a rectangle with a base of 10 and a height of 4, or a length of 10 and a width of 4. Now in a parallelogram, we refer to these things as the base and the height. The base being 10, the height being 4, and 10 times 4 gives us 40 centimeters squared. Okay, area always having that centimeter squared because that's referring to one little square being full, and in total there are 40 squares on the inside of this shape. Now, our formula that we use then is base times height. And remember, the base and the height must meet at a 90-degree angle to one another, meaning they must be perpendicular to one another. You'll need that word next year. Okay? When I'm looking at perimeter of the parallelogram, I don't care about the height. The height was 4, but I don't need the height because the height is really on the inside of my shape. I don't care about that. My little walking stick man needs to go around all the outside lines. So he's going to walk from the top right corner down 5 centimeters, and then 10, and then 5, and then 10 again. So when I look at the perimeter, it was 5 plus 10 plus 5 plus 10. And in total, that gives us 30. And because those were side lengths, it becomes 30 centimeters. Okay? Centimeters because it was a bunch of lengths added together, versus area, which is centimeters squared, talking about how many little squares are in the inside of our shape. Now, I don't really have a nice way of simplifying this perimeter. I call it base and, not height, sorry. We might use like S for slant height. So generally what I've seen in the past is S1 and S2, just referring to side length 1 and side length 2. It would be really similar to what we have for a rectangle. 2 times side length number 1 and 2 times side length number 2. And then that would be the same as 2 times side length 1 plus side length 2. But again, I don't really need a formula for it. I just need to know to add all the outside lines together. And there's parallelograms.